In Module 10, we will finish Chapter 6. We will continue to talk about conditional processing. So this video, we will talk about conditional loop. Before we did talk about loop, actually it's a conditional jump. Because for any loop instruction, before we jump to the code label, we will check if the ECX not equal to 0. So if not equal to 0, we will jump. However, additional to the loop, we have more loop instruction. So we have LOOPZ and LOOPE and LOOPNZ and LOOPNE. So the first one, let's talk about what is the LOOPZ and the LOOPE. So for the LOOPZ and the E, you can guess. Actually, that's according to the 0 flag. So after the comparison, if the 0 flag is set, that means the two values we compare, they are equal. So actually, when you use the LOOPZ and the LOOPE, fundamentally, they are the same. They will check if the 0 flag is set. So that's why, like earlier, we talked about for the loop. Remember, regular loop, we will decrement ECX by 1. So then if ECX not equal to 0, so then we will jump. So now here, actually, our loop E and loop Z, they just according to the original loop. Then we add one more instruction. We add the 0 flag equal to 1. So not only your ECX should be greater than 0, and the 0 flag equal to 1. So here, be careful. Even here, we write ECX not greater than 0, right? So actually, this one you can change back to not equal to 0. Because anyway, ECX, if we don't specify, we only consider they are positive value. So it's kind of like ECX is not equal to 0. So if before we talk about loop, we say is you decrement ECX and ECX not equal to 0, that makes more sense to you. You just remember is ECX not equal to 0. But to go to the loop, to jump to the destination, for the loop Z and the loop E, you need to add one more condition. So this one is our 0 flag need to be set. So then we will jump to the destination. Of course, this destination just means the code label. So when we will use the loop Z and loop E, so you see here, because the 0 flag is set, so that's why I go back to the loop, right? So that's why here, when we're using for the loop Z, is the condition when we try to scanning the array. So we want to find the first value is not matched for the given value. Okay, why? Because you see, if the 0 flag is set, so that's the value we try to compare. They are always the same, right? So that's why your 0 flag will be set. So we will continue if the value is the same. But if the first one is not matched the given value, so our loop will break from the loop Z. So that's why when you want to check your array, you try to scanning your array elements one by one. So when you need to use for the loop Z, you need to consider is you try to find the not match one. Because if they are matching, I just go back to the loop. Only when the ECX is equal to 0 or is not matched, so I leave the loop. Okay, so the same thing, you understand loop Z and loop E. So now you will know the NZ and the NE. That means if the 0 flag is clear. So that's why the same thing here. Let me change. We just say is not equal to 0. Okay. So then usually the loop will always decrement ECX by 1. So if the ECX not equal to 0, then we jump. But now here, if we use the NZ, you need to make sure the 0 flag is clear. So that's why NZ and NE, they are the same. They are the same conditional loop. So the NZ and NE is, So why we need to have loop? Because we usually try to scan in the array. But for the NZ, we will try to find the first match for the given value. Why? Because if they are not matched, right, that's why I need to go back to the loop. I continue to check. Okay, so that's the conditional loop. Here we're using one example to see which conditional loop we should use. So this example, we say, that's fine, and print the first positive value in the array. Print 0 if not found. So for example, if I have an signed array, signed word array, so we have the value here. So what we want to do is we want to find the first positive value. So then we will return that value. Otherwise, we print 0 if we didn't find that. So on the other hand, you will see if this value is negative number or not. So if this one is negative number, I need to continue to go, right? So then until they are positive numbers, so I leave the loop. Okay, so which loop we should use? LOOPNZ or LOOPZ? The first thing we need to know, how to check if a value is negative number. If this number is negative, I need to continue to go back to the loop. Did you remember how to check a number is negative? Right, if this one is the 2 byte, so we leave that value into AX. So this AX, if that's negative number, that means the most significant bit will be 1, right? Okay, so if you remember in the previous chapter we talked about, so we can use the AND operator. So if your most significant bit is 1, so then if I AND 1 0 0 0 0 0, so then if they are still 1, so then I know this value is negative number. So did you remember that, right? So here actually we should use the AND instruction. But remember why I don't use the AND? Because AND instruction, after the AND AX with the value, the AX value will be updated. But if I don't want the AX value to be updated, the test is not change the AX, but they will do the AND instruction. Okay, so if this AX is negative number, so the most significant bit will be 1. So remember A000, actually this one is how many bytes? 001 byte, right? A01 byte, right? So that's why here is 2 bytes. So sometimes if we want to write 2 bytes, but only the most significant bit is 1, you just need to write like in the hex like this. Why? Because the first 12 digits, they are 0, but 8 equal to 1 0 0 0. So that means here you see you try to AND a 2 byte value with 1 0 0 0. Any number AND with 0, we will clear that bit. So if AX is a negative number, so 1 and the 1, they will be 1. So that's why if AX is a negative number, after I do the text AX with 8000 in hex, the result will be not 0. So on the other hand is 0 flag is clear. So if the 0 flag is clear, that means they are negative number. So that's why I need to continue. So that's why I need to use the loop NZ for the loop. I try to compare each element using the test instruction. So if this one come back, 0 flag is clear, that means I need to go back to the loop to try the other one. Okay, until if they do the test AX 8000 is 0 flag is set, so then there will be the positive number. On the other hand, I need to leave the loop. Okay, so that's why this one we need to use the loop NZ to do that. Okay, so here is our logic. Our logic, actually, we need to set our ECX equal to the size, the length of the array. So then, because if the zero flag is clear, that means I need to go back to the loop because they are negative number. So that's why in this case, I need to use the LOOPNZ. So if they are negative number, I use the LOOPNZ to continue. So if not, so if this condition is not true, I leave the loop. So on the other hand, actually, when I come back to the loop, I only have one condition. Both ECX need to be greater than 0, and zero flag is 0. Zero flag is clear. However, when I leave the loop, actually I have two situations I will leave the loop, right? One situation is, actually I go over all the element, but even the ECX becomes 0. I still didn't find that. Okay, so then that means it's no positive number in here. So that's why I need to print 0. However, I have the other situation is, if the 0 flag is still clear, right? But then actually the ECX, the 0 flag is clear, okay, then that means it's not found. So then you will print the first positive value. That means the 0 flag actually equal to 1. So when the 0 flag equal to 1, then you will print the positive number. Okay, so we see the complete code. So that's our original array. So we put that array here. So then you will see the ESI actually is the indirect addressing for our array. So that's why in the loop, our loop we call next. So the next is according to the ECX, is the length of the array. So now each value, we need to use the word pointer to test with the 8,000 in hex. So now here we see what's this one. Actually, this one is push the flag. Then pop the flag. We see why. Because remember earlier we said, after this test, we will check the 0 flag so we can jump. But if right away I put this loop right after the test, I will just jump back to the next, right? Then I have no way to increment my ESI. So that's why after the test, before the loop jump, I have to increment my ESI. But if you add ESI here, the flag will change. So that's why here we do the push FD and pop FD is we want to get the flag status is holding to the test. So then here I push to the stack. So after I increment, then I pop the flag again. So then here, right, I will see if this 0 flag is clear, I just need to continue to check. Okay, so that's the first part. So after we finish that conditional loop, what happened? Remember earlier we said we had two situations, right? The first situation is I leave the loop because ECX equal to 0. That means we finished, we didn't find that. Or one situation is I finish the loop. So then I leave because the 0 flag is set. So that's I need to print the next one. But one thing is need to be careful because after we test, we increment right away. So on the other hand, when we test the 10 will be doing the test instruction. They will be 0 flag will be set. But afterward, I test the 10, right? I will increment to the next one. So then my ESI will point to the next one. So that's why when I leave the loop, actually I need to be careful. When I print the 10, I need to decrement by 1. Okay, so this script actually is how I print the result. But one thing we need to be careful before we print the result, right? Because I want to use the right int. So that's why I need to use EAX. So then here when I sub, because I need to get on the previous one, I find the result.